Dear students, welcome back to my YouTube channel. I'm Silicon Cube and this is an online chemistry tutorial. And you get my previous videos from my personal homepage or from my YouTube channel. And we were discussing the topic molecular rearrangement and transformation from the part reagents and transformation in organic chemistry. And today we are going to discuss Benzil-Benzilic acid rearrangement. Rearrangement reactions are interesting class of reaction wherein a group or an atom migrating during the course of reaction. There are two types of molecular rearrangement, intramolecular and intermolecular. Intermolecular means the migrating group is first detached and later reattached at another site. Intramolecular means the group that migrates is not completely detached from the system in which rearrangement is taking place. There are many types of rearrangement. Rearrangement can happen to electron deficient carbon atom or to the electron deficient nitrogen atom. So first we are discussing the rearrangement to the electron deficient carbon atom. This is fourth one, Benzil-Benzilic acid rearrangement in such class. So what is Benzil-Benzilic acid rearrangement? In this rearrangement, alpha diketone, this is a diketone, this compound, you have a two carbonate here, and alpha diketone treated with the base and it rearranged to give a salt of alpha hydroxy. You have an hydroxy group here, alpha hydroxy carboxylic acid or acid. So you get this product. So diketone in the presence of base, it gives alpha hydroxy carboxylic acid, and one of the alkyl or aryl group get migrated to the next carbon, that is 1,2 rearrangement take place, and you have two aryl group at the same carbon atom. And for example, there are many examples. One, the most important is Benzil-Benzilic. That is benzil means two phenyl group. Here you have two phenyl group in diketone, and name is benzil means 1,2-diphenylene ethane 1,2-dione. That is benzil. Benzil in the presence of base, it gives benzilic acid. This is benzilic acid. Benzilic acid means the name is 2-hydroxy 2,2-diphenyl acetic acid. So you have an acetic acid here, and at this carbon there are two phenyl group and two hydroxy group. This is called benzilic acid. And finally, the benzilic acid is getting after acidic hydrolysis. So there are some points to be remembered in this rearrangement, and usually this reaction is mainly illustrated with aromatic compound. There are many examples of aliphatic or semi-aliphatic or heterocyclic substrate. That is the one point. Second one, if you are using alkoxide instead of hydroxide, so what product you get? You get ester. So if you are using hydroxide, you get acid. If you are using alkoxide, you get ester. And the reaction is this reaction, and this reaction is reversible actually. But the driving force for the reaction is you can remove this product, the salt, by ionization of carboxylic acid. So this is the driving force of for the reason for getting the product. Actually, it is reversible, but because this product can be removed, then the equilibrium will be shifted towards the right. And another point is it's an intramolecular disproportionation reaction. That means one center is oxidized and another one is reduced. So coming to the mechanism of the reaction, and this is benzil, and the first step is the attack of hydroxyl group. Hydroxyl group can attack the electron deficient center. You have two electron deficient center, the carbonyl, and this lone pair on this oxygen is nucleophilic. This can attack this carbonyl carbon position that is electrophilic, and this double bond break. And you get a tetrahedral intermediate like this. This is tetrahedral intermediate, and you have an O minus here and OH. And in this step, this intermediate collapse and it undergo a rearrangement. First, what happens is this the lone pair on oxygen, it form a pi double bond, and by giving off this electron towards the air, it forms double bond. Then either this hydroxyl group has to leave from here, or phenyl group should migrate. Here what happens is the phenyl group, once the carbonyl group is formed, the phenyl migrate towards this next carbonyl, and it is a 1-2 migration. Then this double bond, carbonyl double bond break as shown here. This carbonyl pi bond break here. So you get a product like this. You have when this single bond becomes double bond here, and you have this OH here, and phenyl is moved towards the next carbon atom. So you have an hydroxyl group here. Then this, in the presence of base, this hydroxyl group, actually what happens is this will be O minus, this will be O minus, and this O minus get this proton from this carboxylic acid, and it forms a salt. Okay, so deprotonation of acid to make this reaction irreversible. So this forms a salt. This can be removed from the product. Then the reaction will be for the equilibrium of reaction will be towards the product direction. Okay, that's about mechanism, and this mechanism is similar to semi-pinnacle rearrangement. This is semi-pinnacle rearrangement, and this intermediate is similar to Benzil-Benzilic acid. Only the difference is instead of carbonyl, you have an halide here. Okay, so here in this reaction in semi-pinnacle, this oxygen become the pi bonded, then R migrate towards this carbon and the halogen left. That is the difference. So breaking of CO pi bond is taking place in benzilic acid instead of leaving halogen in semi-pinnacle. Or this may be sometimes hydroxyl. And next one is examples for benzil-benzilic acid. The first one is this the dicarboxylic acid, and in the presence of base, it can attack this carbonyl carbon, and it become hydroxyl group, and this O minus become double bonded. Then what happens is this group get migrated towards this carbon atom, carbon, and finally you get a citric acid like this, citric acid. Another example is this diketone, cyclic diketone. In the presence of base, what happens first is it attack this carbonyl carbon and it form a intermediate like this. Then this O minus, it become pi bonded. Then what happens is this bond has to break, and this carbon migrate towards this carbonate, and this double bond break, and it become a cyclopropane, hydroxycyclopropane carboxylic acid like this. And the third example is similar to this second one. And first, the hydroxyl group attack as shown in previous example, and it form an intermediate like this, and a cyclopropane based hydroxyl carboxylic acid product will be formed. And fourth example is glyoxal. Glyoxal, you have an aldehyde here and a ketone here, and in presence of base, first jack the aldehyde and it form an intermediate like this, an intermediate rearrangement like this. Here the migrating group is the H minus. This H minus get migrated, and that H minus, you can see it here, migrate towards this carbon atom right here, and the product is called metallic acid. So you can convert glyoxal into metallic acid by Benzil-Benzilic acid rearrangement. So in summary, rearrangement reactions are interesting class of reaction wherein a group or an atom migrate during the course of reaction. And in benzilic acid reaction, alpha ketone treated with base and rearranged to give salt of alpha hydroxy acid, and this is finally acidified. And this reaction is usually illustrated with an aromatic compound, but also give a there are many examples with a aliphatic or semi-aliphatic heterocyclic substrate. And if you're using alkoxide, usually give ester, and the reaction is reversible. The driving force for the reaction is the removal of product is possible by ionization of carboxylic acid. Okay, that's all. Thank you for watching.